Select the major product of the following series of reactions. So if we look at the starting material that we're given, we see that we have a diester. And the first two set of conditions here, there's sodium methoxide, a base that matches the ester, followed by treatment with HCl. These are the conditions to do an intramolecular Claisen condensation. So in that reaction, what you're going to do is you're going to deprotonate the alpha carbon of one of these two esters using that sodium methoxide. And it doesn't matter which of these two esters is going to be deprotonated at the alpha carbon, either this one or this one. So I am going to go ahead and I'm not going to show the mechanism for the deprotonation. I'm just going to go ahead and show the enolate that would form from that first step. And from that then, this enolate can attack the next carbonyl in a Claisen condensation. And so these electrons would then come up onto the oxygen and back down and kick off the leaving group. So we're going to take a shortcut here to draw the product. So we'll acknowledge that this is a shortcut and not a valid mechanism. But it is a nice, fast way to get to the product and to save yourself some time. So what we're doing here when we do this intramolecular reaction is we are forming a ring. So we want to count from this enolate to the carbonyl to see how many atoms are going to be within this ring. So 1, 2, 3, 4, 5, and 6. And we know that ring formation is favorable when you can form a 5 or 6 membered ring. So we will say that after the steps 1 and 2, that we will have formed this 6-membered ring. So let me go ahead and draw the ring. Okay, so there's 6 carbon atoms. So we will start here as 1, 2, 3, 4, 5, and 6. And it doesn't matter where you start numbering, it's completely up to you. And then we just want to make sure that we're going to put everything back on here. So we saw off carbon 1, we have this ester. And then off carbon 6, after we've attacked that carbonyl, the electrons come up and back down and kick off the leaving group, you'll be left with a carbonyl or a ketone there at carbon number 6. So that is the product of that first intramolecular Claisen reaction. And so in our next step, we're again treating this with a base. So we're going to deprotonate the most acidic hydrogen in the molecule, which will be the hydrogen that is in between those two carbonyls. So another equivalent of base will be added, and this will be removing that most acidic hydrogen. So now we're forming another enolate. So this is after step 3, adding more of that sodium methoxide. So we can go ahead and draw that enolate. All right, and so this enolate is a nucleophile, and what we're adding in the next step is an electrophile. So if we look at step 4, we are adding in an alkyl halide. And so your alkyl halide is electrophilic at the carbon that your halogen is attached to. So your enolate can attack that carbon and kick off the leaving group, that halide ion. So we will have added now an ethyl group to this carbon in between the two carbonyls. So we can draw in the ethyl group that we've added. And now in this final step, we're going to do a hydrolysis. And so this is going to hydrolyze your ester to the carboxylic acid. So that is a long mechanism, one that we talked about in a previous chapter. And so you have videos on that if you want to look it up. But so you're going to hydrolyze this ester to the carboxylic acid. And we still have that ethyl group off the same carbon. And as we heat it up, also part of step 5, we can decarboxylate. So as you heat this up, you can lose the CO2 group here, which is going to give you the substituted ketone, which we can hopefully see matches this option D.